Building the Great Pyramid was an astonishing achievement. There are 8 major feats of engineering involved in the building. First, the builders leveled the ground and cut a 6,000-hectare bedrock to fit many strangely shaped slabs, each one as heavy as a car. Second, they carried 130 granite blocks over 500 miles. Each block weighed between 12 and 70 ton. The blocks were hauled up 210 feet, an achievement which even today would be a challenge. Third, the Great Pyramid has 3 chambers inside it. With breathtaking precision, the builders cut a passage through the solid rock, 300 feet long by 3 feet wide, to reach the lowest chamber. Pier Luigi Coppet, an architect who helped create the Berlin Potsdamer Platz, seems surprised.
The descending passageway was narrow, so the working conditions would have been terrible. Keeping the tunnel at exactly the same angle would need special tools. You would need precision tools throughout the whole building process.
Fourth, the builders worked with more than 2 million pieces of stone, all of different shapes and sizes. This makes accurate building much harder. In spite of this, the upper chamber is perfectly horizontal and vertical. The builders got it right to within a 50th of an inch. This is a feat any modern structural engineer would envy.
To build things so accurately such a long time ago is it's frankly amazing. And even now, I think most people would say it would be too difficult for most builders to get anything like that accurate.
And it worked. The Great Pyramid stayed intact through earthquakes that flattened everything around it.
Everything was in its proper place, and nothing had moved inside.
Fifth, the position of the Great Pyramid is absolutely precise. It points north within 0.05 of a degree. We only learned to do this recently. In the 17th century, thousands of years after the pyramid was built, they couldn't come close to that degree of precision. Sixth, the Great Pyramid actually has 8 sides. Building an 8-sided pyramid is even more complicated than building a 4-sided one.
To keep this 8-sided base on the 4 sides of the edifice during the build, with an accuracy down to a centimetre, even down to a millimetre, this would have been extremely difficult. If we wanted to build a structure like this today, even using all the modern measuring devices and building techniques at our disposal, we'd still be in real trouble.
Seventh, they worked at speed. Egyptologists think the pyramid only took 20 years to build. There are over 2 million stone blocks in the pyramid. If they worked 12-hour shifts, 365 days a year, they'd have to quarry, carve, lift and fit one block every 2.5 minutes. And finally, since the ancient Egyptians didn't have wheels, iron or steel, the 7th wonder of the world was built with copper chisels, stone mallets and hemp ropes. So, 4,700 years ago, when the rest of the planet was still wandering about in animal skins, the ancient Egyptians flattened a limestone hillock, paved an area the size of 6 football pitches, piled up 2 million blocks of stone to the height of a 42-story building, drove a narrow 300-foot-long passage utterly straight through the rock, fitted the stone in the inner chamber with complete precision, built the outside of the pyramid with 8 sides instead of 4, and made it earthquake-proof. lined it up precisely with magnetic north, and got the whole job done in 20 years using only these.
You might think the Egyptologist is overwhelmed by written evidence. This is true for some periods, but for others, like the ancient empire, we know very little. And that's why, finally, your questions are ours. When it comes to the building of the pyramids, we have a lot of theories, but no written account.
The pyramid is thought to be the tomb of the pharaoh Cheops, although we have little historical information about him.
As with all the Egyptian pharaohs, we don't have any proper historical records.
There is evidence in papyrus and carved into the rock, but no one can agree on what it means.
There is no agreement among Egyptologists. They look at the evidence on the ground and sometimes conclude one thing and sometimes another.
So if the historians and Egyptologists can't tell us how the Great Pyramid was built, maybe we should ask geologists, stonecutters and engineers, men with technical know-how, the people who do these kind of big projects in our own time. In the 1960s, engineers raised the Abu Simbel temple to keep it from being flooded by the Aswan Dam's water. In spite of cranes and trucks, it took 5 years to quarry and rebuild this temple made of 2,200 blocks, some weighing 30 tons. It was a huge achievement, but nothing compared with building the Great Pyramid. This clay quarry in France is roughly the size of the Great Pyramid. It took 12 years to fill it, and all they were doing was dumping rubble. They didn't have to build a thing. Maybe it's time to think the unthinkable. Maybe the Great Pyramid isn't a tomb. Maybe it was built for something else. There are other sites in Egypt where blocks of uneven shape and size are used for building, but nobody knows why.
For me, this remains a complete mystery.
Without cement, those are rough stones laid side by side. This is breathtaking. These are tremendous achievements.
A razor blade couldn't fit between two blocks. They're so precisely laid. It can't have been easy.
Heavy blocks like that haven't been put back in place anytime recently.
Here the blocks are irregularly shaped, but they're a perfect match with the blocks on the other side of the corridor. A mirror image. So they can't have been set as they came, using whatever irregular shapes came from the quarry. They must have been carved into these shapes on purpose. There must be a reason for it.
If you want your monument to stand strong, it needs to be heterogeneous. That will keep the wall from collapsing in the case of stress, like in an earthquake.
Since there are no modular blocks, there are no crack lines. The blocks fit into one another, which makes for a strong wall.
So the builders of the Great Pyramid over 4,000 years ago knew how to make their work earthquake-proof. Eric Gontier sums it up.
Objectively, from my own observations on the ground, each time I checked a pyramid systematically, everything had to be reconsidered.